Welcome everybody to this webinar on branching and merging patterns in modern distributed version control. My name is Tim Ströbele and I will be your host for today's webinar. And I'm glad to have with me Pablo Santos on the other line coming from Spain. Pablo is the founder of Codiz Software, who built the configuration management system Plastic SCM, probably one of the very innovative products we see nowadays on the market. And Pablo will lead most of the session today. So he will have like 45 minutes of today's webinar. And I will briefly hand over to him after like 5 to 10 minutes introduction about Polarion, what we do, what our product is doing. So a warm welcome to you, Pablo.
Thank you for the presentation. Yes, I'm here and ready to jump in when it's my turn.
Okay, great. So let's get started. So a few words about Polarion. What is Polarion? Polarion is a product. The Polarion product is called Polarion ALM. ALM stands for Application Lifecycle Management, and basically it means whenever you have software, you build software or software is part of your product, you need to manage the different phases of your software, and ALM stands for Application Lifecycle Management. So it means starting from the requirements to the test cases, to the issues you need to track, to the defects you may find, to the changes you have, and changes we all know, we have a lot of changes when it comes to software, and all related reports and builds, and also when it comes to variant management. This is all part of this big ALM solution that Polarion provides. One of the exciting things actually is that it's not a set of different products, but that all is in one common platform, and so it is easy for you to extract different type of value management information to have better control of your project. It is 100% browser-based, so it means you have a pretty small footprint on your clients. You just need a web client basically to work with Polarion. It is 10 years old, so the architecture is built for the web, and you can adopt it to your way of working. So it's not like that's the way you should work, and Polarion ships with only one way to work in a project, but you can have several types of templates for different types of disciplines like Agile, like V-Model, and you can also embed your own way of working for sure. One of the key points of Polarion is that it allows you to trace and track all the information, which makes it very helpful when you have audits or when you work in regulated environments. You can trace down a requirement if you want from the initial idea down to the last code change that you did. And when you have everything in one system, one of the beauty of it is that you can then easily extract real-time information on the data on your project. A few words about our business footprint. We have now currently around 100 people in the company. Polarion operates worldwide. We have offices and partners in more than 20 countries. Currently, more than 3 million users use our product with more than 98% of renewal rate. We are pretty proud on this. Many of our customers have many-year contracts for renewal. We grow steadily and strong, and 55% are new customers, 45% expand their engagement in Polarion by adding new disciplines. It doesn't mean that they install any new product, but basically they choose a different type of license and they get a new feature set. There is also something like an app store which allows you to download more than 200 extensions. Some of them are workflow extensions, processes like for special sectors like medical, there is a MedPack, or for ISO 26262, and many other small extensions. Most of them are for free. You can just download them and have your special customized Polarion. Polarion is available in the cloud if you like, or you can install it in your IT infrastructure and host the server by yourself. As I said at the beginning, you can use Polarion practically anywhere where you have software, or software is part of your product. But as it turns out to be, Polarion is especially used by companies who work in highly regulated areas like medical, defense, banking, pharma, where it is key to trace and track every information. Here you can see just a a list of our customers. You will find detailed stories how they implemented Polarion and what they saved and the benefits they got on our homepage. Also sometimes with some videos and testimonials. So please check that out. I won't spend too much time on this now. As this is the case that many of our customers are working in highly regulated environments, we took time and effort to do the same with our product. So Polarion ALM is fully approved by the TÜV Nord regarding IEC 61508 or ISO 26262 for the automotive area. It means basically that Polarion was checked for if it's possible to use Polarion in these highly regulated environments, and we got the approval, which means that our customers in these environments, they still need to approve the products and check the products they use, but it's much easier for them because they can draw back on the use cases used by the TÜV during this assessment and this test. You may imagine that, or you may think that this makes the product maybe complex or hard to use when you have so many disciplines which are supported. But actually, I think we did a pretty good job to still make it easy for the end user to work with the product. And so let me just give you some short impressions of how Polarion looks like. This is the homepage, and let me just start with a little search here where I search for some keywords. And what I find here is all the artifacts that are inside. We call these work items. So they have different icons here. So you see it's different types of artifacts. So a requirement, for example, or this DP224 is a test case. And there are also documents. So everything is fully indexed. And it's quite easy for me to drill down in one of these artifacts and find the document which is containing this artifact. And now we are in a requirement specification document. And creating new requirements is really similar to using Word. So you just hit enter and it behaves like a bullet list. And this is a new requirement, and I save it, and now a new item is created. It gets a new process is started with all the defined workflow that you lay in your process behind these objects. You can work in parallel on this document, so I could edit this part here on top while my colleague can change something here in the bottom. So that's the way how you can actually easily create test specification, requirement specification. And as all this information is tracked as single objects, you can also work on the object as you may be familiar with tracker systems. Now, when all the data is in the system, you can create some quite nice and helpful reports. For example, this one showing you which requirements are covered by what test cases, and maybe even what defect here was created by that test case. This means actually you don't anymore focus on specific parts of your development, but you always have the full width of the information. So you can drill down to any aspect you are currently interested in. And there are different ways to visualize that. For example, more like a coverage information telling you what is covered, for example, by test cases, or what is covered by own requirements. The typical question that you have in projects is always, did I cover everything that my customer wants, or did I forget maybe something? And these reports help you because it will give you confidence that you have at least covered everything which is required to cover. And then for sure you can manage all this in different ways. One example could be the planning aspect. So you have tracked your artifacts and now you want to see the progress. You plan it to a specific version, and plans can contain sub-plans. It's a multi-project management system meant to be used in really complex environments. You can use it also in small single projects, but the beauty or the benefit really is if you have big complex projects, because then you can drill down from the high-level project down to one iteration, showing you the progress, showing you even the single task where somebody was working on, related maybe to some requirement. That's a different type of traceability here, because now we look more into the planning aspect of our traceability. And this task may be assigned to developer. The developer may just check his own homepage and sees, well, there's something I need to do, something I need to implement in my source code. And that's the point also where I would like to hand over to Pablo, because now we need to check out some code, we need to work maybe with branches, everything which is needed to change the code, and there are good practices how this could be done. And I'm very curious now on Pablo's presentation about the branching and merging practices.
As Tim said, I'm going to be talking about a little bit of branching and merging and how it blends with distributed version control. Well, I'm Pablo Santos. I'm the founder at Covite Software. We develop Plastic SCM. We are completely focused on version control. Well, my agenda for today, I'll be basically following the steps you have on screen right now. I'll be talking a little bit about Big Bang integration, how it evolved to continuous delivery, how version control is a key component there. Then I'll explain a little bit of the branch for task pattern, which perfectly integrates with the Polarium way of working and blends the worlds of version control plus the requirements and issue tracking and task management. I'll also go through merging, a little bit of the basics. It's going to be very quick, but especially for people who's less familiar with the concepts behind merge, I think it's going to help making everything clearer. And then I'll be covering a little bit of distributed and multi-site, and then just jump straight into a demo with Plastic SCM. And then we'll talk about the synergies and the integration between Polarium and Plastic. And of course, at any point, you can just ask questions. So, well, to start with, there are many version controls out there. So why is Plastic different? Why we came up and developed a new version control? Well, we've been in business for already 9 years. We started back in 2005, and we always wanted to come up with a distributed version control system that can also work centralized. So it's like blending the best of both worlds. You can do branching and merging in a very simple and powerful way. You have very rich graphical user interfaces. You can also work on the command line, but you have a good GUI. We have security, which is not only good to prevent, unwanted access. It's also good for enforcing policies, like you can only check in on tasks that are already open or in branches that are associated to tasks or stuff like that, right? And it's reliable and scalable, so you can grow up to hundreds and even thousands of developers. We have different setups around the world, from very big ones, really huge ones with more than 1,000 developers on the same code base, to smaller ones, some well-known names from insurance companies to mobile manufacturers to, universities, banks. So there's really a wide range of customers using Plastic SCM. Well, a little bit about the Plastic structure, right? As I said before, it's a distributed and centralized version control. We focus on branching and merging. For a lot of people, especially using products like CVS or Subversion and other systems like that of that age, they are a little bit scared about branching and merging. Now, I'll be showing today that's a little bit different with Plastic. It's easier and it's safe to do. And of course, we also focus on the visualization. What you have on the screen right now is a branch explorer. It's a graphical view of the evolution of a repository through time. It's not just a visualization. It's something you can touch, you can use on a daily basis to work. I'll be focusing on that later on. The main components, well, we have a server. You can set up more than one server depending on your configuration, even a small server on each developer machine for fully distributed. We have different clients, from integrations with popular IDEs to command line client to the GUIs. The GUI client basically performs on the command line client, so on. They perform all the basic version control operations. The server can be on the same machine, on a different machine. The server can scale up to use standard database backends like MySQL, SQL Server, Oracle, or can be using an embedded database for really small footprint work on a laptop, for instance. That's the setup I'll be using later on during the demo. Well, let's now jump to the key in my presentation, which is how branching and merging help on day-to-day operations. At the beginning, everybody was using Big Bang integration. This is basically the root cause behind a lot of failures in the software industry. You start working, then you start making some features and more features and more features, and then at the point in time you decide to integrate, to merge back. Okay, the thing is that while you do that, you are not alone. So chances are that other parts of your team are doing the same, or other teams in the same project. This is basically all about the famous life cycle known as the waterfall, right? You just develop, and then at a certain point in time you merge. The integration phase is supposed to be short, but it isn't at the end of the day. So something you expect to get up and running in a week ends up taking sometimes even longer than the project itself. This is what is called Big Bang integration. You delay it till the end, and then you have big trouble. Of course, it doesn't have to be this way. Maybe you don't really wait until the end, but you don't integrate or merge so often. Things change, of course, with agile methodologies and especially incremental life cycles and iterative life cycles. I would say incremental mainly. And then what you do to solve this is basically merge more often, integrate more often. So if you reduce if you increase the frequency, you basically reduce the problem. At the end of the day, you are doing the painful thing more often till it's not painful anymore, right? So this is how you break the Big Bang problem. And the thing is, in doing that, version control can help a lot. Can help you managing the map between the tasks you use in Polarium, you create in Polarium, and how you work in your code and how you merge it. And that's going to be basically what I'll be covering during the rest of the presentation, from the concept part to the demo. So what's the branch per task workflow, and what is its significance? Well, the branch per task is very simple. For every task in your issue tracker project management system, in your ALM, like Polarium, you create a branch in your version control. So there's a one-to-one link between the project language and the developer daily work. This is a very important thing for me, because sometimes if you're working on a mainline, just a single branch or a few branches, but not a branch for each task, you are a developer, you are working, you know you're working on task 105, right? But okay, you're just checking in, so you are not so into how the project is being managed. But this way, you really touch the project instruments, the assets, the elements, right? And you get a much better and deeper understanding. So you get lots, as a developer, you get a lot of freedom to merge, to develop, to keep the mainline pristine, avoid broken builds, which are some of the things I'll be covering now. And also the branch becomes the unit of change instead of the chain set. At the end of the day, the branch is just a way to group different related changes together, right? So what are the requirements for branch per task? Well, you need a version control system that is able to branch super fast. We have customers with code bases of 100,000 files, 200,000 files, 500,000 files. When that happens, you cannot wait a branch to be created in minutes. You need to happen in milliseconds. In fact, in Plastic, the size of the code base is not related to the branch speed. It doesn't matter whether you have one file or 100,000 files. The speed to create the branch is always the same, because there's a copy is not happening, right? You really need a strong merging, and this is something I'll be covering in detail. Branching is just the first step, right? But you need to merge the code later, and well, we consider that good visualization is of course a blast. The benefits: you avoid product freezing, you help avoiding broken builds a lot. You help removing unwanted links between the tasks, and you decide what goes into the next release, and you can try out different ideas. Let me put an example. We work with several companies in the gaming industry, so when they approach a release of the game, before they used to do a code freeze. No one makes a check-in except the people really fixing the last important bugs, right? But what happened now that every team has to release new downloadable content for each game? What you do, you have like 20 people, 30 people, 100 people just sitting around working but not able to check in. That's not something you can do. That's why branching helps a lot there. Let me just jump into the first case study. Well, serial development is widely adopted. It's a widely adopted workflow, and looks like this, right? You have several check-ins with a number, and you associate tasks to each of the check-ins. So, for instance, in this case, task 127, you made 2 check-ins associated to it. But you have a problem here. The problem is that in between these 2 changes, you made another 2, completely unrelated. And let me explain why this can end up being a problem. Well, the thing is, at the end of the day, when you created task 132, you didn't simply do just something like this, right? Okay, you only made a check-in into your version control, most likely. But what happened? Well, the developer was working during 3 days because it was a difficult task, and made a couple of changes the first day, more changes the second day, and even more changes on the third day. But all these changes are outside version control. If you only check in at the end of the 3 days, that's something you completely avoid with brancher tasks. Why this is a bad idea? First, the version control is only a delivery mechanism for the developer. It's not giving him any extra value. Of course, you'll have to back up the developer machines or something on a daily basis in order to avoid losing data if something goes wrong with his workstation or something. So there's a way to solve that, and I'll be covering that in a second. The second thing is task dependencies. Well, task 127 was made in 2 check-ins, right? But what happened if the developer broke the build in check-in number 13? He probably fixed it later on number 16, but in between, what happened? The build was broken, affecting the whole team. That's something you don't want to happen. That's something you want to avoid. And one of the things to avoid that is, one of the ways to avoid that is using branches. Of course, you can tell me, hey, but I'm using continuous integration. Well, continuous integration will tell you you broke the build, but the build will be already broken, right? What we introduce with branch per task is the ability to avoid that part. Of course, branch per task is not mandatory at all. In Plastic, you can use any approach you want. That's simply one thing we enable. Okay, how this same example looks like using branch per task. Look, every task has its own branch. You check in often, creating intermediate changes, and when you are ready, you merge back to the trunk. So you can even test every single task in isolation before merging, or during the merge process, you can try to make sure everything is okay, right? So you avoid breaking the build, which is something that was actually happening here, right? In this previous drawing I showed you. So that's a little bit of the branch per task. Of course, you need a version control that's really fast branching, that has really good, strong merging, right? There are other ways to do this. Like, for instance, some other continuous integration systems are trying to avoid you checking in the code into the trunk before the code is tested, but instead of using a branch, they do some other exotic solutions simply because the underlying version control is not able to do with branching. Well, let me now jump a little bit in merging. Really quick intro. You all know about this, right? Okay, 2 developers working on the same file. They do changes in different parts of the file. There are 2 ways to do this, right? Whether one does his job first and then the other starts. This way, the total time will be the sum of the times each of the developer takes to do the change. Of course, they can work in parallel. They'll do the 2 changes at the same time, but then they'll have to merge it. The beauty of Plastic, the beauty of all systems that are good with merges that help you implement in this way and solving this merge. And then let me explain a little bit about this merge part. You, of course, need a merge tool and also good version control to track the merges. So what's the difference between 2-way merge and 3-way merge? The developers change line 30, but look at the 2 files. Who changed it? It was you or it was me? You don't know. So every 2-way merge tool needs to ask the user, as the developer, for every conflict, which is painful and takes a lot of time. It's something you don't want to do when you're doing large-scale software development. What happens with 3-way merge? Well, in 3-way merge, you know how the file was. So if you know how it was, you can immediately, automatically detect who made a change. Look, I didn't make a change. You made a change, so it's safe to just keep yours. You don't even need it. Of course, the version control can be configured to still ask the user, but you don't even need to ask the user to solve this. You can safely choose this version. That's what a 3-way merge tool does. It's not, of course, exclusive of Plastic SCM. We do a good job here. We provide our own 3-way merge tool, but it's just a little bit of theory, right? So what happens with manual resolution? Look at this. Now, in the base, which is how it was, yours, one of the changes, mine, the other contributor, there's one line that actually changed in two ways. This is where the merge tool will help you. Okay, there are two divergent changes happening here, so which one should I keep? This is where the tool will ask you for help, right? Otherwise, all the other conflicts are automatic, which means in practice, 90% of the conflicts when you develop in parallel in different branches are solved automatically if you have a good three-way merge system. And of course, if you look at my diagrams here, look at this. You see the merge arrows? These green arrows all around? We don't only render them. We don't only draw them because they are beautiful. We do that because it helps us finding the ancestors. So when you merge 13 with 15 in order to produce 16, we know the base was 3. I'll explain a little bit more about that, right? But the concept here is good version control plus good three-way merge help you implementing branch per task. Okay. So, well, we jump in this one. Well, in our website, we have a place called the Merge Machine where we explain how we compare with all other version control systems in some difficult merge cases. Like suppose you move a file to a different location and you also change it. And at the same time, this file was changed on the original location in a different branch. Plastic handles that like nothing. It's very, very simple to deal with. But it's a big problem for other systems, right? This is just one of the examples. We also develop, since we focus on merge technology, we also developed something called Semantic Merge. And Semantic Merge is a standalone product that you can integrate not only with Plastic, but with any other version control system, Git, Mercurial, Perforce, Subversion, anything. And it's the only version, is the only merge tool able to parse the code, works for Java, C, C#, and merge based on that, which means it applies the same techniques we apply in Plastic for different files inside each file to actually merge based on understanding that a class is a class, that a method is a method, that an attribute is an attribute, right? Okay, let me jump back from merge into multi-site. Nowadays, it's very common that teams have several offices around the world, right? Or that different teams inside a big company cooperate together in the same code base. So when that happens, multi-site helps you a lot, and that's something you can do with Plastic. You have an office in one place, another office in a different place. They connect through the internet, and they can push and pull changes, branches actually in Plastic, between them. The good thing here is that you don't need the guys on this place to be connecting over the internet to this server for daily check-ins, which will be slow. That is what happens with regular centralized version control systems, right? In our case, we can have as many servers as you want and push and pull between them. Of course, we also enable fully distributed, which is basically, okay, what happens if you have developers working from home? They can have their own repo if your internal policies allow you to do that, right? And then they can push and pull between them directly. That's something that Plastic can do. Or even more interestingly, we can have mixed modes. You can have local developers working at the office, checking in with a server, pushing and pulling to different sites, and then you can even have roaming developers working from home, right, at certain occasions, and that connecting through replica to the central sites. So that's a little bit about the wide range of options you have with Plastic, right? It's not only about branching and merging. It's not only about branch per task. It's also about fully distributed and multi-site and even mixed development, where some developers work in central mode, in, let's say, Subversion style, only working copy and then they check in. Some others work in fully distributed way. They check in and also push and pull, and different sites on different parts of the country or even on different continents collaborate with each other with push and pull. Okay, so that's a little bit of the concepts of the theory. And now I'll jump into Plastic, if that's okay. I don't know if there are any questions pending. Any pending questions, team?
There was one question whether you can, when you rename a file,
okay,
or if you can track that in a merge.
Yes, of course.
If it's possible to. Okay.
We can do that. We can track it. Okay, for some reason I have an interaction with. Okay, I lost my mouse, so I need to connect another one or something because my trackpad is not working. But I'll be answering this question in the meantime. So yes, one of the things that Plastic is very, 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 really good at is that tracking files that have been moved or renamed to different location or whatever, right? And then merging them again. What I'm going to do is exactly what, I don't know if there are any other questions. Otherwise, I'll jump into the demo, right?
This was in the chat. No, so far no other questions.
Okay, so I'm going to demo exactly that case. So let me start. First thing I'm going to do is label my, well, this is the Branch Explorer. This is the GUI client in Plastic SCM. I'll be focusing today on the GUI client. Of course, you can do the same from the command line, not visually, of course. You can do the same with inside Visual Studio, Eclipse, all that, right? But I'll be focusing on just on the GUI. Okay, so the first thing I'm going to do is label my main branch, create a new label. Suppose we are going to release and code, so I'm going to label my branch, right? I'll call it BL500, baseline 500. Okay, here we go. Of course, you can use any name you want according to your naming conventions. The first thing I'm going to do is to create a task. It's going to be a task branch, right? So normally I will name it after one of the elements in Polarium, right? In my case, for instance, I will be calling it something like a DP. For instance, I'll call it DP89. DP89 after the same issue in the same entry in Polarium. It will be a task in Polarium. And then I'll do something like rename a file and fix a bug. Okay, here we go. Okay, here we go. And the branch is created, and I'll just jump to the new branch. As you can see in the Branch Explorer, I'm now on the new branch. Okay, the next thing I'll try to do, okay, I'll really try, but...
I can imagine how difficult it is if you don't see the mouse.
Yeah, it's very hard, and it's an interaction with WebEx for some reason. Okay, so now I'm there, and the thing I'm going to do is to rename a file, make a change, and show you what happens, right? I'll use a file called FileSystem, okay? It's a C# file. I'm going to open it up in Visual Studio, and now I'm going to make a change. So I'll change this comment first, okay? And now I'll just do something simple, right? Just, this is a bug fix. Of course, I wouldn't comment the code this way normally. And suppose I change this by 10, which is not very safe, but anyway, I save my file, go back to Plastic, go to my pending changes view, and then I see my file has been modified. But let me do something else. Let me do something interesting. I go back to my items view, and I'll go and open my Windows Explorer. Okay. Wow. Okay, here we are. And then I'll go and go to this FileSys, which is inside Code Cgame. Code Cgame FileSys. Okay, look at what I'm going to do. I'm completely outside Plastic SCM control. I just cut the file, and I'll put it inside this this directory called merge. And after doing that, I'll also rename it to file system. Let me go back to Plastic, go to pending changes, refresh, and see what happened. Plastic detected that the file has been changed and moved outside its control. It's telling me, look, it was moved from Code Cgame file system to merge file system. So not only renamed, but also moved. Since it is still very similar to the previous one, I know it's the same file. Of course, you can make life easier to Plastic, and you just can move the file in the items view in Plastic, so you can tell Plastic, so you just tell Plastic, hey, I moved it, right? What I'm showing you right now is what we call the transparent version control, which is Plastic detects what happened for you. So checking and move file. So this is the first thing. I check in. If I go to the Branch Explorer now, you see there is a first check-in there. I can zoom it. I can go on diff. If I go on diff, you see that the file was changed and moved. And I can even inspect the change in my built-in diff, as you can see here. And you see perfectly that I actually I actually remove a comment, add another one, and change a value there. So the next thing I'm going to do is create another branch. I'm going to call it DP90, and I'm going to do something interesting here. First thing I'm going to do is find my FileSys Okay, as you can see now, the file is again on the old location. Why? Because I'm no longer in this branch. I'm on this one. This one's starting from the common point where the rename didn't happen. The rename actually happened on the other branch, right? So what I'm going to do here is go and change the file. Okay? So what I'm going to do is, remember before I changed the value to 10, now I'm going to move it to 20, right? And I'm also going to add another comment. Comment added on task 90. Okay? I save, I check in, and I'm going to show you how to check in from different locations, not from the pending changes, but just from here. Okay, and first file checked in. Next thing I'm going to do, which is very simple, is make another change so I can show you what happens when you do more than one check-in on the same branch. Okay, I'll do something simple, which is just remove some comments, then I go and check in, file change. Normally you will be using more interesting comments than the ones I'm putting here, of course. Go back to the branch explorer, and you see I have a couple of check-ins on the same branch. This is basically parallel development. The two lines are evolving in parallel. Let me do something now. I'll go back to the main branch. Now the house icon is there. I'm simulating a couple of developers working on the branch. Of course, it's just me, right, working on two branches, but it could happen with a couple of developers. And now what I'm going to do is to merge the two branches back to main. So the first one is going to be this one. Let's merge first the simple one. If I div this one, you see that there are two files that were changed, the file sys, and also the cg snapshot.c, where I removed some comments. Let's now switch back to main. I'm already on main. Let's merge this branch first. It's very simple. Right-click on the branch, merge from this branch. I merge. Plastic shows me what's going to be merged. I tell OK, proceed. And then if I go to pending changes, it tells me, hey, you have a merge link in progress. You have a couple of files that have been just merged. And if I go to the branch explorer, I see a clear explanation of what's going on. There's a merge link going on telling me you are merging. It's still in dots because the merge didn't finish. Go back to the pending changes, and I'll do something like first merge back to main. I check in, go back to the branch explorer. Now the merge link is a real one. It's not temporary anymore. And let me now go and merge the second branch. Let me first make sure I have the right tool configured to merge. This is not something you will do on a normal basis. Just let me move it a little bit. So like this, okay. And here we are, okay. So the next thing I'm going to do is to merge the branch 89. And remember, there was something special with this branch. Okay, Plastic is telling me what's going on. It's telling me, look, this branch, this file system has been changed on both source and destination. Why? Because it was actually, let me show you explain merge. And explain merge is telling you, look, this is the base, this is the destination, this is the source, and it's telling me you change it here, but it was also modified there because this is a result of a merge. Go to the real branch explorer, you see what I'm talking about. When I merge this to there, this one was already modified by this one, right? So it's telling me that, but it's detecting the move. So let me process the merge and see what happens. Plastic is able to merge, is able to apply the move, the rename, but still merge with the other file I modified in parallel. So remember before I had this line, right? It was 0, one of the contributors changed it to 10, and the one that actually I merged before changed it to 20. So now I have to decide which one I want. In my case, I don't want the base, of course. I don't want the destination. I will just keep the source, but you know what? It's going to be 30. I do that, I save and exit, and if I go to the branch explorer, I get the second merge in progress, and I was able to merge a file that has been renamed, moved, and modified in parallel. This is part of what Plastic SCM can do. Some other interesting stuff. Let me just check in this change. Go to pending changes. I check in. Second check in. Okay. Remember, I told you a little bit about working in in a distributed way. Well, from the Branch Explorer, there are other places to do that. But from the Branch Explorer, I can go and do things like replication, push this branch, or pull this branch. Push this branch means push it to a different server, right, or to a different repository. In fact, I have something here called, I'm working on a repository called Quake. Let me now go to Quake Replica. If I go to Quake Replica, this is a replica of the other repository I was working on. But as you can see, it doesn't have exactly the same branches because the replicas didn't still happen. Let me show you something. I can do something called show me the remote change sets. I'll do that. And as you can see here, I have a lot of changes that are drawn in a discontinuous way, right? In a dashed mode. These are all the changes that are coming from the main repo. And there is baseline 500, which I still don't have on my repository here, 500, and also all these branches and the changes and so on. The first thing I'm going to do is replicate this branch. So replication, pull this branch. I'm going to pull it from the Quake repo into the Quake replica repo, replicate, replica happens. Now it's happening in my own machine, but of course it makes a lot more sense when it happens between different servers. And then I'll be introducing the new data. Actually, there's a lot of data because I checked in a lot of big image files in between. So that's why it's taking a little bit more. And now, when it's finished, you'll see something changing in my Branch Explorer. I click on close, look at this change sets here, and now they are not discontinuous anymore. Now the changes are on my replica. One of the big advantages in Plastic is that it allows partial replica, so you don't need to clone the entire repository when you replicate. Well, that's a little bit about the branch per task cycle, which we already follow. We create a task, we merge it, actually a couple of tasks. I explained you in action how merge works, and well, it's time to explain a little bit of how Plastic and Polarium work together, and we integrated Plastic with Polarium. So yeah, there's a plugin working in Polarium which is able to get data from Plastic repositories. So I'll show you a little bit of that. So if you are in Polarium, you can go and link your task with different, with tasks inside Plastic. You can go and see the linked revisions, and then go and link to a specific revision inside Plastic SCM and so on, right? So, can you show that? Yeah. Well, that's what I'm trying. If you see my screen, I'm in Polarium right now, and I'm trying to get. But I'm using virtual machine for this Polarium server, and sometimes a little bit slow. But it's the fault of my virtual machine and the network, not the Polarium or the plugin. So basically, what the plugin lets you do is to browse information of Plastic when you are in Polarium, right? For instance, I can just type here my info. And if I tap it correctly, which I don't know, you will be able to see information here inside Polarium, right? But the interesting thing, here we are, right? So you can see the change set that I linked to, and you can even see the diffs. Of course, you can also check that later when you are inside Polarium. You can see the diffs and so on, right? So the point here is that Plastic by itself is not able to do the whole job, right? You actually need something like Polarium to handle the tasks, handle the requirements, and then Plastic is like the last mile. It's the part letting you handle the code, handling the actual tasks that you manage with Polarium. And that's a little bit of the integration and how the two products make sense working together. Well, I think we are approaching the last minute, so if you have any questions, I'll be more than happy to try to help.
So let's see if there are any questions. I see something in the chat. There is, what about, so I have here there are some questions. Let me just close this poll here. So the first question, how about branching and integrating binary files that cannot be merged?
Okay, that's a very good question. Well, we work with a lot of teams that handle binary files that cannot be merged, like game teams in aeronautic industry and stuff like that. Well, for that users, we implement locking too. So you can lock a file and prevent it to be modified while you're working on it. Most likely with binary files, you won't be branching them. You'll be probably working on the trunk, or if you branch, you'll be locking and making sure no one works in parallel on that. Of course, you cannot merge those files, but we introduce locking, which is, well, basically the way to solve the problem. We don't recommend locking for regular use, only for unmergeable content.
I guess that's the answer. I guess the question is related to locking of binary files.
Yeah, it's what we call exclusive checkout or locking.
There was another question, but I think you answered it already in the demo. It was how the integration with Polarion works. I think we've seen that.
Yeah, it's exactly what you can see on the screen, and we are working on improving it step by step, so there will be more to come. Right now, you cannot see information of Polarion from the plastic side, only from plastic in the Polarion side. The next step will be showing info from Polarion in plastic. But at the point, at the current stage, it's already fully usable. Things that we, of course, will continue with our partnership and improving it step by step.
There is one question also in the chat. Is it possible to integrate like build automation tools in plastic?
Yes, we integrate with a number of different systems from Final Builder, Jenkins, Bamboo from Atlassian, really different systems out there. So from open source to commercial, it's very easy to integrate with CI tools.
So I think that was the last question. Thank you, Pablo. It was very interesting to see what is possible with merging. I think this is great, being able to rename files automatically. I'm very curious about this technology. So thanks everybody for joining this webinar. Again, you will receive a download link if you want to share the webinar with your colleagues and friends. And hope to see you soon in one of our other webinars. Take care and have a good day. Bye-bye, everybody.
Thank you very much.